Hello everyone, good afternoon and welcome to our today's webinar. I'm delighted to have you all here with us. We have an exciting and insightful webinar here featuring one of our senior software engineers, Anisur, as the speaker. He has been involved in this project for a while. Before we begin, I just want to mention that your participation and engagement are very important to us. If you have any questions during the webinar, please feel free to ask them in the Zoom chat. We will address them during the Q&A part of the webinar. Without any further delay, let's dive into the program. Over to you, Anisur. You can continue.
Hello, everyone. I think my screen share perfectly.
Yeah, it's visible. We can watch it.
Well, my name is Ansur Rahman. I work as a senior software engineer at AppScott, and welcome everyone in today's webinar session. So our today's webinar title is Introducing Full and Continuous Backup with Point-in-Time Recovery for KubeDB-managed MSSQL Server. So let's go to the main slide deck. Here is the overview section that I would like to discuss in today's webinar. So first of all, the first thing is overview of MSSQL Server Archiver custom resource. And then the next topic is understand point-in-time recovery in database disaster recovery world. And the next topic is full and continuous backup architecture, which comes up with KubeDB and Kubestash integration. Then the next topic is demonstration of the backup process of a sample MSSQL server. And after that, we'll also showcasing our point-in-time recovery feature. And the last section will be question and answer session for everyone. So yeah, here is the overview section of the MSSQL Server custom resource. So basically, this custom resource is managed by KubeDB. So disaster recovery for MSSQL Server Archiver in Kubernetes ecosystem is quite challenging. So KubeDB-managed MSSQL Server Provisioner simplifies it with a rich disaster recovery solution. So the MSSQL Server Archiver custom resource is a helping hand of this feature. So basically, this resource is designed to hold the backup information. For example, first of all, it holds the target database selection level. This level selector is used to specify on which database the user want to start archiving. Then it also holds the full backup and log backup information. For the full backup, it holds the configurable schedule, retention policies, and history limits. All of those parts are from Kubestash. So if you want to learn more of this term, you have to go to the kubestash.com, which is also another project of AppScott. Then the next things that archiver hold is log backups information, like the history limits, the successful log backup history status limit, and the failed log backup status section actually. So it also holds the runtime setting, so which will be used in pod runtime section. Another things that the archiver hold is backup storage reference. That is also the term of Kubestash. So which actually gives you hold the information on which platform, which storage platform you want to use to keep your backup data. For example, Google Cloud Storage, Amazon AWS S3, or Azure, or any public or private cloud. So it also hold the data encryption secrets, which will be used to take your backup with a secret, encrypted secret. So overall, it ensures the point-in-time recovery. Here is the part of point-in-time recovery. So in this slide, we'll know a little more about what is point-in-time recovery in database world, what it stands for. So what is actually the point-in-time recovery? So point-in-time recovery allows you to restore a database in the state that is in a specific time. So for example, just focus on this photo. If your database backup plan are designed that way, as the full backup will trigger in a 12-hour schedule, and the log backup will trigger in 5 minutes interval schedule. Then there is a full backup, and the interval time there are lots of log backups. So if a disaster scenario occurred in 12:30, then that's mean that you have to restore first the nearest full backup, which will be the 12, and the meantime of your disaster scenario and the last full backup, there are lots of log. So you have to restore all log one by one, and this mechanism is known as the point-in-time recovery. So it reduces your data loss as minimal as possible actually. For note down, our KubeDB-managed MSSQL Server provisioner takes log backup in 30 seconds interval. So by 30 seconds interval, we try to maintain a minimal data loss as possible actually. Okay, this is the full and continuous backup architecture. In this section, we'll explain a brief overview and the mechanism how the full backup and log backup works in KubeDB. So first of all, a user have to create a MSSQL Server database, which are managed by KubeDB. And KubeDB provisioner operator watch this MSSQL Server database and start provisioning. So once the provisioning is done, database status will go into the ready section. So once the database is ready, the user again create a MSSQL Server Archiver, which holds the necessary backup information. So the provisioner watch this archiver and patch the database object with the reference of this archiver. So once the patching is done, the provisioner operator first create a backup configuration. So this backup configuration is a part of Kubestash. So therefore, the Kubestash operator watch this backup configuration. So the backup configuration holds the necessary backup information, as I mentioned earlier. For example, the full backup schedule, and then retention policies, a store limit, and many more. So yeah, actually, this full backup will trigger a cron job and with your user specified schedule time. So this backup configuration is responsible for full backup. So and user can provide customizable schedule of full backup. For example, a daily, weekly, monthly, yearly, or whatever user want to take backup actually. So once the first full backup is done, I mean the corresponding snapshots of a specific full backup is done, then Kubestash provision will create the sidekick. And what is sidekick actually? The sidekick is another custom resource are managed by Capscode, and this is the upgraded version of sidecar native Kubernetes resource. So this sidekick is responsible for triggering the log backups in 30 minutes time schedule. As you can see, there is a full backup, and after that there are lots of continuous log backup, and all of those backups will be stored, will keep in a cloud provider storage, cloud storage, or any public or private storage actually. So there's the whole mechanism of continuous full and block backup works in KubeDB along the integration of Kubestash. So let's move on to the next slide. So this slide is a demonstration. So first of all, I'd like to go to my terminal. So here, the first thing first that I want to apply a sample MSSQL server in this cluster. So for this feature, you have to apply, you have to install the Kubestash and KubeDB. So for the simplicity, I previously created both of these application by using help. So as you can see that I applied KubeDB. My cluster has installed KubeDB and Kubestash both with the version of 2024.12.18, and Kubestash version is 2024.12.9. So let's apply the backup sample MSSQL server first. So as you can see that I applied the YAML of sample MSSQL server. So this server is in provisioning state. So until this MSSQL server goes in ready state, let's discuss the YAML a little bit. So this is my MSSQL server YAML look like. So I said the archiver level archiver is equal to true. That's mean if the actual archiver resource has this level, then provisioner start archiving this database. And I am for the demonstration, I am using availability group topology mode, and I keep the database only one as named by demo. And also I'm using the issuer ref, and we are using cert manager, which is CNCF graduate project for this TLS certificate management actually. Here is the basic information of MSSQL server. If you would like to know all of the feature of MSSQL server and what the every YAML section, the explanation of every YAML section, then just go to the KubeDB.com and you will get under the MSSQL server database section, you will get all of this information. So you see that the port is in initializing section. So it will take 2 or 3 minutes because of it will pull all of the necessary image to get to provision the database. So during that meantime, let's talk about the a little about the archiver. So here is our archiver custom resource. As during the slide explanation, I said that archiver MSSQL archiver is a custom resource which hold the necessary information to take backup. So yeah, you can see that there is a selector label is archiver is equal to 2. That's mean that our sample MSSQL server also has that label. So that's mean this will be this SQL server will be the candidate of a continuous archiver backup actually. So here is also the retention policy. This is another custom resource. This is the namespace name reference of the retention policy, which will be used to prune the full backup. Here is the encryption secret reference. This is will be used to data encryption actually. And you can see this is the full backup information. This full backup info under the full backup section, you can see there is a schedule of how much interval we want to take backup, take full backup, and this is also shows the history limit. And under the log backup section, there is a log spec. You can see that we set the failed log history limit is 2, and the successful log history limit is also 2. That means the Kubestash QB provisioner create incremental snapshots. So under the status of this snapshot, there will be a section of log states, and these log states will show the failed log status and successful log status. And this limit is the how much status, the count of this status that user want to see for the debugging purpose. Here is also a backup storage reference, which contains the information of on which cloud platform you want to take backup, keep your backup data actually. So for our demonstration, we are using Google Cloud. So pod is still in initialization phase. That means that the image is already is pulling. You can see that the image is pulling state, so it will take some time. It depends on your internet. So let's wait a little more until it pull the image successfully. So if you want to know a little bit more about the backup storage YAML, let's discuss a little bit because of the provisioning taking so much time. So meantime, we can describe a backup storage more. Yeah, here is a backup storage that we are using in this demonstration. So this is the another custom resource. It's owned by Kubestash. Yeah, you can see this is in storage AP version using and inside the spec and storage provider, you can see that the provider is GCS, and we mention our bucket name. Prefix is MSSQL Server Webinar, and secret name GCS secret. So we said our deletion policy is equal to wipeout. So that means during the deletion of backup storage, all our backup data will be deleted from cloud storage. So yeah, the pod is in running session as our replica was too. Let's wait a little more until the pod goes to the provisioning states. Once the pod go to the ready states, it will trigger backup configuration as far as our design. So if we get the YAML of MSSQL Server, you will see the list of conditions which from which you can get the information, the progress of provisioning. So it still shows that the phase of SQL Server is in provisioning state. So it will take more time to go to the ready states. Let's wait a little more. So yeah, it shows that the database is in ready states. Just wait a little more until it triggers the backup configuration. Oh, yeah, we mentioned that our storage reference properly in our cover section. So yeah, definitely it will trigger a backup storage. Let's talk about a little bit more about our MSSQL server. So yeah, you can see that the archiver section are added in our spec section. And yeah, actually it already triggered our backup configuration, but the configuration phase is in not ready phase. Yeah, right now you can see that the backup is successfully triggered. And full backup is successfully triggered, and the full backup snapshot is also in running state. So once the full backup snapshot is succeeded, the KubeDB provisioner will trigger the sidekick, and which will be responsible for applying the log backup. So let's insert some demo data to the uh, database so that the log backup takes backup those sample demo data. So we are using a custom authentication secret named by MSSQL custom auth. So for that, we have to view the secret. So let's view the secret and go to the shell terminal and insert some demo data to the database itself. So this is our authentication secret, and this is our username. So for the simplicity, I already note down the command. So let's apply the command one by one. And meantime, you can see that the sidekick is created. And once the sidekick is created, provisioner will also create the sample SQL Server incremental snapshot. Basically, these snapshots will hold the start in time and the log status of the log backup. So let's insert some sample data first. So we are already in the terminal, shell terminal, and we are using SQL CMD to insert some data. So we are using demo database as we mentioned in our YAML section. So I just giving the command one by one. So I'm creating the schema of equipment table. Then sorting some data. So it shows that the data inserted successfully. Just to verify that data inserted successfully. Yeah, you can see that the six data inserted successfully. So if we restore from our database, then six data definitely will restore. So let's talk about a little bit about our MS SQL Server incremental snapshot. So basically, these snapshots holds the log status of every transaction. So if we get the YAML of this YAML, we will see and discuss briefly. So I just get the YAML of incremental snapshots. So under the status section and under the component log component section, you see there is a log status section. So inside the under the log status, you can find the information of archiving starting information and archived ending information, and also the last succeeded status, which shows the individual log backups in start and ending times. And there is another section of total succeeded count is equal to 3. That means that until now the 3 successfully log are backup are taken. So if we get YAML again, then definitely it will be shows that 4. That's mean after in every 30 seconds interval, log backup log backup is working. So yeah, actually this component status section shows the necessary information. You can set any uh, you can set the history limit, whatever you want for our demonstration process, as we stated the last successful log backup history limit is 2. So therefore it shows only the 2 status of successful log backups. So you can set the same way for the failed backup also. And if any fail backup exists, in that case, there will be another section as total failed count, and definitely it will be the count of total failed backup. So yeah, this is the is very informative part from incremental snapshots. So now we have to create a disaster scenario by hand. So right now I am going to delete the sample MSSQL server. So let's apply, let's delete the sample MSSQL server by hand for the creation of disaster. You can also log the sidekick pod for more debugging. So I also want to show all of you how the log backup internally, how the log backup pod logs look like actually. So yeah, you can see that this is the how log backup works actually. So let's delete for the log backup first. So I deleted the sample MSSQL server, and once I deleted the SQL server, the incremental snapshots status will be in succeeded. That's mean that for till now, for the targeted SQL server log backup are succeeded. So now we have now time to point in time recovery. So for point in time recovery, I'm going to apply another MSSQL server, which named restore MSSQL server. And under the init section, there is a section called archiver. And in that section, we have to provide the full DB repository and the recovery timestamp. So from where we will take the recovery timestamp. So if we get the snapshot, incremental snapshot, then we can find the in time of log backup. From there we can take the last successful log backup, and this is the time of successful log backup. Just copy this one. So we can provide it by hand. So we 10, 40. So I'm taking 42 for current time. So just apply this one. So I'm going to apply this YAML. Yeah, as you can see that the restore MSSQL server are applied, and first of all, it will apply the restore session, which will be responsible for restoring the manifest first. So the database status is in provisioning state. So let's talk about the little bit about the manifest and the full backup as well. So if we get the YAML of the full backup, then we can see that there will be a section of full backup and YAML backup. So those YAML will be restored first, and the restore session YAML is in succeeded states. That means that the YAML restore successfully completed. Now KubeDB provisioner is doing the database provisioning. So in that meantime, we can see, we can discuss and see a little more about our archiver full backup snapshot. So under the status component section, there is a two component. One is dump and another is manifest. The dump is full backup information, and under the wall states, you can see there is a database section, and we only take full backup of demo database. And under the manifest section, we are using Restic to take manifest backup, and it stores the database in the directory in that part of our cloud storage. And this is the status. So let's wait until the database goes to ready state. So if you want to see the data, how the backup data are kept in backup cloud storage, we can go the cloud storage console and see how the database stored actually. Our backup storage name was bucket name was Kubestash QA. So this is our bucket name, and if we go to the directory, this is our SQL Server webinar prefix under, and there is a directory, of sample backup, full backup, and there is a snapshots of two full backup. One is archiver, and another one is two snapshots. One is archiver, another one is incremental backup. So if you go to the repository section, definitely there will be a directory for log backup. So under the dump, so yeah, here is a wall backup. So if we go there, we can see that all of those are log backups. So yeah, it sees that database is in ready states. So just wait a little bit more, then database will trigger a full backup. So it will take some time to get reconcile of KubeDB provisioner. As I am using client cluster, it's quite slow to get response from KubeDB SQL Server resource. And you can see that our full backup restore session is triggered, and the pod is in running states. Just wait a little until our full backup restore complete. So we can log this pod to see how it's going. On the time, database will go into the restoring phase. You see that the database is in restoring phase, then definitely the log backup is running. Full backup is in running session. Once the full backup restore is done, then the KubeDB provisioner will trigger a sidekick a custom resource. This sidekick custom resource will responsible for restore log backup one by one until the immediate interval time between the disaster recovery, a disaster, and the full backup time actually. So yeah, it shows that our full backup restore is in succeeded state. So just wait a little more until it triggers a sidekick. We can know a little more about the restore session. If you get the YAML of restore session, you can see that all necessary information of status like conditions, and this is the status of full backup restore. So it takes 30 seconds and the phase is in succeeded actually. So I guess our log backup are successfully completed. Just wait a little more until it complete actually. So yeah, you can see that our log backup is started. Just wait a little until it complete actually. So once it done, that's mean our disaster recovery is finished. So after that, we will query again to check that our sample database are restored successfully or not. So we can see this log. So if we log this log restore report, then definitely we'll get more information at how log backup is going actually. Log restore is going actually. So yeah, you can see that all of log restored successfully and finish restoring. That's mean our disaster recovery successfully completed. Now let's exec the one of the pod of restored MSSQL server and verify that our data has been created successfully. So I'm going to use this. So we are in the interactive mode, so where we can run our query. So just verify that the database, our demo database is created successfully. So yeah, you can see that the demo database created successfully. Now use this demo database and verify that our equipment table data restored successfully. Yeah, it shows that our backup database restored successfully. If we go in some above, then definitely we can see that those data are backup during the time, and after recovery, all of those data are recovered successfully. So yeah, that's the point in time recovery along with continuous log and full backup with the integration of KubeDB and Kubestash. So this is our today's webinar demonstration. So and here is the question and answering session. So yeah, if you want to answer any question, then please feel free to ask.
This is Ishtiak.
Yeah,
I have a simple question to clarify a doubt.
yes.
So at first, thank you, Anisur, for such wonderful and informative session. Actually, my question is, can we take backup externally managed my MSSQL as you have showed us a demo for KubeDB-managed MSSQL? So is it possible to use this feature for externally managed MSSQL, or is it just for KubeDB managed MSSQL?
Well, right now we are only considering the backup and restore process for only the KubeDB managed databases. but we are planning to integrate this feature as soon as possible. But for rest of the database like MySQL or many more, all of those database has this feature like externally managed database. So yeah, thanks for the question. So yeah, we are trying to integrate this feature, and hopefully within 1 or 2 months we'll also integrate this feature also.
Okay, it sounds nice. Thanks, Sunny.
So yeah, any further questions? I guess
Yeah,
there
actually,
is.
the disaster recovery of any MSSQL server is quite a rich feature. Actually, that only the cloud provider has the managed database, managed MSSQL server database service. So KubeDB also has the rich feature with disaster recovery. So yeah.
Yeah, we get it. So thanks, Anisur, for the fantastic explanation with hands-on demo. And thank you all for your participation, and we look forward to your presence in our future sessions. And visit our website appscode.com/webinar to check the schedule and register for our upcoming events. So with this, we are ending our webinar and wishing you all a great day. Bye-bye.
Tata.